Hello everyone, so let's solve Max exam Math A 2015 question 1.8. Okay, so this is a question of first order reoccurrence. Okay, so for the sequence an defined by an plus 1 minus an equals 2an and a1 equals 0, where n is a positive integer, the general term is an equals to what? So a reoccurrence is, we have a sequence that every term is defined by the term that comes before it, right? And a first order reoccurrence, the term that we want, an plus 1, an plus 1, it only depends on the term that comes before it, okay? On the term that comes before it. One second. Here. So, what do I mean by the term that comes before it? By an equals to n, but this doesn't depend on two terms before it, okay? So like if we wanted to know the first term, the first term he gave us, right? So a1, 0. So if we want to know the second term, we can put n equals 1, right? Okay, so we can put n equals 1 plus 1 equals, this minus will go to the other side, so an, but n is 1 plus 2n, right? But n is 1, okay? So notice the difference between this one over here and one down, okay? So a of 2 is equal to a1, what is the value of it? Is 0, okay? Plus 2, okay? So a2 is equal to 2, okay? So now we need to find a way to, now this is how we know that it is a first order reoccurrence. If it was a second order reoccurrence, it would be like plus or minus, maybe an minus 2, okay? So it would depend on two terms before it, okay? So this is why this is a first order reoccurrence. Now how can we solve this? Well, look, let's say if we wanted a of 2, okay, it would be equals to what? It will be equal to a1, look, a of n plus 1 is equal to what? a1 plus an plus 2 multiplied by n, right? Just sending this part over here to the other side summing, okay? So let's try to find the pattern. So look, a of 2, a of 1 we already know is 0, so a of 2 is equal to what? To a of 1 plus 2 multiplied by 1, okay? What about a of 3? Well, a of 3 is equal to a of 2, because it is equal to the term before it, plus 2 multiplied by n, right? So n is 2 over here. Look, what I'm saying is that in our rule over here, in our rule, if we want a of 3, then n must be equal to 2. Why? Because 2 plus 1 is 3, but n is 2, so we put 2 over here, and n is 2, so we put 2 over here, okay? So this is what I'm doing. Now the same thing for a4, okay? a4 is equal to a3 plus 2 multiplied by 3, okay? Because it is multiplied by n. And if we want to have 4 over here, so it will be 3 plus 1. So n is equal to 3. So this n is 3 and this n is 3, okay? So, and this we can do forever. We can go doing for a5, a6, a7, and we can do it for an minus 1, which is going to be what? A of n minus 2. Look, here it was 4. So here it was 4 minus 1, right? Plus 2 multiplied by, here it was 4, here it was 3. So it is 4 minus 1. Here it was n minus 1, so it is n minus 2. And here 2 multiplied by n minus 1. And then we can do it for a sub n, okay? This is how you call it in English, I guess. So is a sub n minus 1 plus 2. Here it is, minus 2, okay? Minus 2. Remember, for all of them, it was 3 here, 3 here, 2 here, 2 here. So here it is 2 n minus 2, so here is n minus 2, okay? And here is n minus 1, okay? So why did we do this? Because now we can sum all of these terms, okay? So look, if we sum all of them, forget this first part, this was just a rule, okay? So if we sum all this part in the left side, so what are we going to have? A sub 2 plus A sub 3 plus A sub 4 plus A sub 5, and there goes forward, okay? And in this side over here, we are going to have the same thing, but A sub 2, A sub 3, A sub 4, A sub 5, okay? Until we are going to have this A sub n minus 1. So these terms are going to cancel, okay? Because we are going to have them in both sides, okay? So these terms are going to go ahead and be cancelling. Look, we have a3 over here and a3 over here, a2 over here and a2 over here, okay? So what do we have left? A1 didn't have a1 over here to cancel, okay? And here we have an, so we have that an is equal to a1 plus, now we have 2 multiplied by 1 plus 2 multiplied by 2 and 2 plus 2 multiplied by 3, and there goes forward, and it goes summing until 2n minus 1. So I'm going to take n outside in this part over here, so an is equal, a sub n is equal to a sub 1 plus 2, and here we'll have 1 plus 2 plus 3 plus 4, and there goes forward until n minus 1, okay? I just took this 2 outside. If you multiply this 2, you'll get back to where we had, okay? So notice that this part over here, it's a sum of a arithmetic progression, okay? Now, how can we sum arithmetic progressions? It is a1 plus an multiplied by the number of terms, okay? Number of terms. So usually it is n, but let's use k here, okay? So k, a k, like the last term that we want, divide by 2, okay? So this was the formula for the sum of the arithmetic progression. So what is the first term? So it is 1 plus the last term is n minus 1. And how many terms do we have? Well, we have 1, 2, 3 until n minus 1. So we have n minus 1 terms divided by 2. Okay, so this part in yellow is going to be n, because 1 minus 1 will be 0, n minus 1 divided by 2, okay? But remember, this part was multiplied to 2, okay? So we will have over here multiplying by 2 and plus a1 equals an, okay? So we will have that an is equal to what? A sub n is equal to what? So a1 is equal to 0, right? Over here we have it. A1 is equal to 0, okay? So a1 is equal to 0, so we can ignore it. This 2 will cut with this 2, so we'll have n multiplied by n minus 1, okay? So this is our answer, n multiplied by n minus 1. Now just to go back in the sum that we did over here, just so it makes sense. So look, what did I do? I basically, it's like I had a equals to x and b is equal to y. So I said that we can sum them, so a plus b is equal to x plus y, okay? So this is what I did over here, okay? In this sum over here, I took this side, the left side, so I said we have that a2 plus a3 plus a4 which are these terms over here, these terms. So I went on summing them until an, okay? So it must be equal to the sum of these numbers over here, right? These numbers. But notice that a2, a3, a4 are going to show here too, so it would be a2 plus a3 plus these numbers over here, okay? But a2 and a3 are going to cut with this part over here, okay? And all we are going to have left is an is equal to a1 plus these terms over here that multiply 2, and then we can represent them. An is equal to a1 plus 2 multiplied by this. So the name of this kind of exercise is reoccurrence, okay? Reoccurrence. It's the second time that it shows on the max exam. The other question was a second order, okay? So this is it.